The first thing we're going to do is we're going to start doing some exercises to just to get an idea of like what Darwin Core is, and so we can sort of discuss it through in groups as to like to get an idea for what these different classes mean in the context of our data sets. So as I say, one of the things is each of the groups will get a cheat sheet. And also, the virtual groups will have the cheat sheet that's in the Google Docs on the Slack channel. I'm just going to load up the cheat sheet now, because I'm just going to briefly go over the cheat sheet with you before we get into the exercises itself. But what I've done in this cheat sheet, so this is a very simplified, oh, actually, I'm still on here. Okay, right, I might just...
I think if you just exit the presentation, it will...
Yeah. Okay, yeah. And then that's Bob's talk. Okay, this is it. Yeah, so you'll see on the cheat sheet, this is basically what it looks like. And what I have not done is reproduced all of Darwin Core in this cheat sheet, because that wouldn't be useful and it'd be overwhelming. But what I've done is I've taken a few of these I've taken a few of these classes, and I've just sort of like had a brief introductory paragraph describing what sort of data type you tend to use that class for, and then also I've then listed underneath it all of the, well, not all of the Darwin Core terms associated with that class, but a list of the more used terms associated with that class. As I say, if you want more information, you can go on the website that I gave that gives you the full definition of each of those classes. But here I'm just sort of giving you a sort of brief overview. And I've taken a few of those classes out for the data site. But there are, again, as I said, there are plenty more classes out there in Darwin Core that can handle much more complicated data types. But I just wanted to give an overview of the most commonly used ones. And I think probably the most commonly used class in Darwin Core for ecological data is this event class. So basically, this is a class to just encapsulate an event occurring at a particular location and time. And so whether that could be a transect, it could be a camera trap firing, it could be you taking a KickNet sample. So basically, as you can imagine, just from the concept of an event, this encapsulates a sort of wide variety of sort of data concepts. And it has a few things associated with it. Usually you have like a unique identifier, so an identifier code for the event. So it'd be like, you know, so if your event, in the context of your event was a quadrat, it could be like quadrat 1, quadrat 2. You could have some ID code. There's other things like parent event ID, which allows you to have events nested within other events. You can say there might be a bigger event, like you've gone out and... So an example of that might be that you've gone out and you've done some, some trawl netting or something like that. And then from that, you've taken some subsamples, and those subsamples might themselves be little mini events. And then from that, you've got some other things. So there are ways to deal with that as well. Often there's like tags like field number, an identifier given to the event in the field, which often links it with your field notes. So if you've had to give it a different event ID number, but in your field notes you have a different number and you want to retain that information, you can place it there. Now, I say I'm not going to go through every single one of these because like we could be here a long time, but it's just to sort of give you a flavour for like how an event is conceptualized in terms of this sort of terminology. A similar one is a location class. So this is when you're trying to describe something about a location, whether it be, and for most ecological data, the locations you're describing normally are a field site. That's probably the most common thing you're going to be describing with a locations class. And again, like that will have a location ID and then other things as well. And like I say, for a lot of location classes, this isn't going to be relevant. So it's like, for example, here, the name of the island group in which the location occurs. Well, if your location is not occurring in an island group, don't use it, ignore it. It's a completely optional term. So I think, like I said, when you first start getting to Darwin Core, you see this and you're like, oh, I need to get every piece of information out of my location class. And you want to fill these all in, even including the ones that make no sense. And so you can fill them in as much as you are able. Obviously, in general, more data is better, but actually, at the same time, just standardizing what you have is very, very useful. Yeah, yeah, the location class goes on for quite some time. You can even put in sort of well-known text representation. So this is when you want to have like shape files. You want to describe a location that's bounded by an aerial unit, like a polygon or something, and so you can describe that polygon there as well. So, like I say, these things are super flexible. And then this is another very common class type that will happen in Darwin Core. This is a occurrence class. So it can exist independently of an event, but normally it sort of happens in consort with it. And this is usually the bit that explains, this is where you've caught or estimated or counted a particular, and so you just say, so this class is just describing what it is about that organism that you've observed. So it's a slightly unfortunately named because it's called occurrence class, and I think for most ecologists, occurrence data we think of as being presence-absence data and nothing else, and we think of actually like population counts as population data. Occurrence class obviously can handle occurrence data, but it can actually also handle many other versions of an incidence of an organism. So for example, again, we have like an occurrence ID, a list of names, people, groups who actually recorded that. And then, like, for example, if you were counting individuals, you could use this, the number of individual represented presence at the time of the occurrence. So if you have some count data, you can put it there. Or maybe it's not count data, maybe it's an organism quantity, maybe it's like biomass or percent cover or something like that. Then you can flag it as an organism quantity. And then, because organism quantity is quite vague, you also need to explain what that is. So it then says, what is it? So the type of quantification system used for the quantity of organisms. So it says, so if you've put 12.5 here, the next thing is like 12.5 what? And you go biomass, if it was biomass. Or like 30% cover, or something like that, if you're using that. And then there's also other things you can use if they're relevant for your system. The sex of the biological individuals, some life stage that are in, the reproductive condition, that might be relevant for something. Behavior for behavioral studies, although spelt the American way, which upsets me, but that's fine. Occurrence status, so this is if you are using presence-absence data, you've gone somewhere, you're just recording whether it's there or not, so then it has two values, present or absent. Or if you want to have lists of media associated with it. So I've seen this, for example, with bat surveys, where you want to tag media such as recordings of the bat calls, and you want to tag that and link that to particular occurrences, and you want to keep that information. And this is a way to annotate that within the data set and explain like where those data files are. And then a list of identifiers of name types of the taxa and associations with the occurrence. So like, what is that occurrence of, basically? So there are... And another class is this taxon class. And this is a class, so this is the sort of, this is probably, this class probably sort of represents the sort of traditional taxonomic roots of TIDVIG, actually. But this is basically where you describe the species that are existing in your data set. So actually not necessarily species, taxon's broad on that, but basically a class to hold information pertaining to a group of organisms which for the purposes of your data set is considered to form a homogeneous unit. So it doesn't necessarily have to be at the species level, like the taxon class is flexible, it can be at many other levels as well. And again, a taxon ID, scientific name, ID, if it's an ID that's recognized in a, so this is actually normally an ID code associated with a taxonomic database. I won't talk about that just now, we might come back to that. Whereas this is what you mean by scientific name normally, so if you're just going to put in the full scientific name, but then you could also put in the different taxonomic levels, the kingdom, phylum, class, order, family, genus, species, and then you can say the taxonomic rank of the most specific name of your genus. So like, basically, your thing you're describing here, what have you managed to ID it to? Have you managed to get it all the way down to species? Have you got to manage it to subspecies? Or have you got it to genus, or you can only get it to family? Or, you know, you can basically just, it's your way of explaining the taxonomic resolution in your data set in a standardized way. And then a vernacular name if you want to, as well, you can put that in as well. And then the taxonomic status, like the status of the use of the scientific name as label for a taxon. So it can't, like, this one's not so often that you worry about this yourself, but sometimes there might be like, taxonomic changes and things like that, which means some of these other information might be out of date or updated. This taxon class, quite often actually, for a lot of biodiversity databases, they often have what they call like a taxonomic backbone. They already have their own idea of taxonomic classification. So quite often, this information actually, you either don't need to fill in yourself, or actually what you can do is just link to the taxonomic backbone you're using and let the taxonomists do the work for you in a way. I think this is something, it's a little bit beyond what we're going to talk about now, but I just want to give a little bit of a pointer that is that actually I think as ecologists we're used to just like typing in our species names in our Excel spreadsheets or whatever, and then we might have typos or things like that, which means then we might end up, when we do community metrics, we might get extra richness because we've misspelled some species, and those sort of mistakes can be quite hard to find sometimes because they're not obviously apparent. I think that's a really common mistake in community ecology. And a solution to that is actually not to bother doing it yourself, is to sort of try and link to a taxonomic backbone, which basically you just give an ID code to the taxonomic backbone you're using. And it also means that if there's a taxonomic revision of some of your species, they get a new name, then actually you're not having to worry about maintaining the name yourself in your data. You're maintaining an ID you're maintaining an ID code in another updated database. So as I don't want to talk too much about that because that confuses things, but I just want to make that people aware that actually I think sometimes as ecologists we tend to do a bit too much of the heavy lifting in terms of the taxonomic descriptions of things when there are like actually quite a lot of facilities out there that help us do that. And then the last one I'm going to talk about now is this measurement or fact class. And so this is this is a really general class. So this just talks about like things you have measured or fact about things, about other classes. So this again, everything always has an ID code, but the measurement type, for example, like if the measurement is about the organism you've measured, it might be the tail length of that organism, but it could also be like abiotic variables like temperature you measured at the field site. Like there are lots of things you can put into a measurement or fact class, but then so you have to say what type it is, and then you have to say the value of it. So if you say temperature, then the next thing will be 16 degrees. But then you can also put in other information about the accuracy around that, like if you know something about the accuracy of your instruments and the measurement units. Again, like I say, it's great if you have all this information, but I appreciate for a lot of data sets you don't. But this is the beauty of the Darwin core. It's sort of quite flexible to implement all of these things in. So when a lot of people say, oh, I don't think a Darwin core standard would suit my data type, it's sometimes quite difficult to see how that can be, because actually the Darwin core data type sort of breaks everything down into events, occurrences, measurements, and all of us are taking measurements as a result of a sampling event normally. Like it's quite hard to see what ecological data doesn't really fall into most of these data types. And so I think actually sometimes actually a lot of the resistance to user standards is actually more a sort of a lack of understanding that actually what you don't need to do is completely reformat your data set to make all your tables look like that and give them these column names. That's not what you have to do. But all you have to do is is to use a mechanism that links your actual data that you actually have to certain known vocabularies. So like, which of the columns in your tables corresponds to the measurement type? Which of the columns in your table corresponds to this? And that allows things to index your data much more easily, because now you've used a standardized vocabulary to describe your data set. So hopefully that sort of makes sense, that it's a little bit beyond. It's not a data format as such. It's a vocabulary type. I'm just going to check how we're doing for time actually.
We're going a bit further than you hoped.
Yes. 13:40. Okay, yes, we're 20 minutes over what we were going to do for the group discussion, but that is fine, because actually what I was going to do is, I think what we'll do is, rather than do, so what I'd done is I'd set up 3 fake data sets. That's how the exercise were going to be. And I was going to ask people to sort of go into breakout groups and then basically sort of look at those data sets and sort of discuss how they would describe those data sets using this vocabulary. But I think what I'll do is, rather than break you all up now, we'll go through one of the first one to get together, to get a feel for just to think about this in a sort of Darwin Corey way. And then what we'll do is we'll break you out into separate groups to do the other 2 exercises. So the first data set I've done is, I've sort of called it citizen science data. This is not real data, by the way. I've just made this up. This is and it's just like a snippet of what a data table would be. But for the sake of argument, imagine this was a data set that's a series of observations made by volunteers in the field who've been reporting georeferenced sightings of birds using an app on their smartphone. The data from the app is then collated into a single table with the following structure, which basically just has like species, XY coordinates, date that was measured, the time it was measured, and then the volunteer's name who collected it. This is sort of like a very classic sort of what we would call a citizen science collect. Obviously, this is actually a very simplified version of even that, because we'd actually collect a lot more information than that. But for the purposes of how we're going to describe that data set, now we would then look at this, and then we'd try and think about what Darwin Claw classes we might try and use to describe this data set. So I'm going to flip back to the presentation. This might be a bit of a problem if it doesn't go back off the presentation again, but we will see. So this is my solution to this, is the way to think about it. So I think sometimes with these like classification processes is I think about it is like, I think about each Darwin Core class as a sort of table, an individual table, and I think about like basically trying to restructure the data according to that table. Now, oh God, it's gone right back to... Okay, so this is the citizen science data. So here we have this event class, and as you'll see in the vocabulary, the event class has a number of things, but the things that are relevant to us that event class can handle is it needs an event ID. That's one of the things that we need to have. But then we have these optional things that we do actually have in our data. We have a date, and we have an event time. So we can make a table that looks a little bit like that. I'm not saying we necessarily do that, but that's a way to think about it. I think that for me, this is my way of thinking about how to like think about things in a Darwin Corey way. And so that is a table one could have of the data. Of course, now it doesn't have all the information at the moment. It's just talking about the events there. So it's the time of which things were measured. And then we also have an occurrence class because we knew something is measured. And again, we have an occurrence ID. And in the occurrence class, there's a recorded by, so we have the volunteers' names, and then we have the occurrence status. Now, in this world, it's only presence-only data because it's citizen science data, so they recorded a presence, recording a presence. Similarly, we go a bit further and we say, actually, okay, let's break it down in a taxon class. Again, just giving it taxon IDs. I just want to point out, these are actually really bad IDs to give it, just 1 and 2. Like, you need to give them way bigger ID numbers than this. I'm being a bit flippant here. Like, ideally, you want to have a code that doesn't repeat very often, and obviously the number 1 and 2 repeats quite often, so it's not a very unique ID to give anything. But anyway, so largely in all my ID columns, but the scientific name here is, yeah, again, we just put in the binomial scientific name. I'm sort of actually breaking, like using the scientific name in this way. I'm not actually doing good practice in the Darwin Core. In that, you'll see examples of it, and I should also be giving authority if I'm going to use the scientific name to describe this. But again, like I say, this is not a real data set, and I'm being a bit lazy for the purposes of this demonstration. And then again, we have some location information in the data, and in that location, we have a decimal latitude and decimal longitude. So we look through our Darwin classes, and we just try to see how much of that is described by these different sort of tables. And so that's sort of how I structured the citizen science data. And actually, I'll explain why it's sometimes useful to think about that way when we get to the next step, which will be, I'll explain that after the exercises. Because the next step is then how we can actually, about particular formats that are useful for like manipulating Darwin Core data. So I'll talk particularly about the Darwin Core archive format later. Now I want to be careful, like there's the Darwin Core standard and there's Darwin Core archive. They are two different things, not to be confused. So what we're doing now is we're just sort of like defining things using Darwin Core terms. So what I want the groups to do now is to look at the other two data sets in the cheat sheet, at the back of the cheat sheet. There's a little description of what they are and what they mean. Sometimes those data sets might be made up of more than one table. And then just to like sort of go through this little exercise and think about like, look at the different classes, like how they would describe that data set using the different Darwin Core classes. Then what we'll do is we'll meet back and then we'll discuss at that point how we'd then go potentially in a sort of how we theoretically then go to the next step to do a Darwin Core archive if we wanted to share that data using an archive format. But as I say, there's some caveats to that, and I'll explain a little bit more about Darwin Core archive format stuff later. But for now, I just want to get people to get a feel for Darwin Core standard stuff.